right, I guess that's what you call a grand entrance. Welcome back to day 2, ladies and gentlemen. It gives me great pleasure to welcome you back here today for the Drones for Good Awards. Today, you're going to be witnessing the national and the international team battling it out for a chance to be crowned #1. And boy, can I tell you, we have a great lineup for you today. Shaban can tell us a little about the first team who we're going to introduce to set up, and then we'll give you some details on what to expect today, too.
So I'm going to tell you about the first 5 teams. You've got Biocarbon Engineering going up first, followed by Drone for Right to Life. Drone for Right to Life, by the way, are working on a refugee crisis solution. Forefront Robotics are up right after that. They're from Canada, and they're working on a very, very ultra-mobile VTOL. They're followed by Avy. Avy is one of the fastest drones we have at the show over here, and it's a hybrid VTOL, so it's part aircraft, part quadcopter, and followed by team number 5, which is Skycart, and they're working on a drone delivery solution.
All right, great. Now, as you're all aware, the Drones and the AI and Robotic for Good Awards was launched under the direction of His Highness Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the UAE and the ruler of Dubai, and the award reflects a strategic direction of the UAE government, which emphasizes the importance of early adaptation to new and emerging technologies to stimulate innovation in the humanitarian sector, which it has an active role. Today, we will witness 10 teams in the international category.
Correct.
And also 10 teams in the national category?
9 teams.
9 teams in the national category. So 19 teams up on the stage today. Let's run through the hashtags for you also. Hashtag UAEA4G is the hashtag for today. Also a quick look at our People's Choice Awards. All right, here in the audience, you can vote for your favorite teams by logging on to the website a4g.ae. for a chance to vote for your favorite teams. We're giving you some more details about the different teams as we go on throughout the day. So get yourselves a nice comfortable seat, get those cameras ready, and I hope you're ready for a great show. All right, I think we're ready to start with our first team who's presenting here today, and the team is Biocarbon Engineering. Please put your hands together for Biocarbon Engineering, our first team today in international drones.
This is a story about one of humanity's greatest challenges. This is a story about Earth. Every year, 15 billion trees are destroyed, and despite heroic international planting efforts, a net loss of 6 billion trees remains. For the 1 billion people who live in these forest communities around the world, this is not just a loss of trees, this is a loss of healthy ecosystems, biodiversity, food, and jobs. Cutting down trees has a tremendous impact on climate change. It causes a loss of soils, and it creates droughts and other natural disasters that displace people, creating millions of environmental refugees. Globally, this affects the supply chain for everyday weather shock companies to be able to source raw materials. This has become big business. Now, governments have recognized this, and commitments have been made to restore 350 million hectares. This is an area the size of India. With the current hand planting methods alone is impossible. They need help. For the last 2 years, and while I was wandering through the deserts of Peru for 4 years, searching for life on Mars, I gotta tell you, I spent a lot of time thinking about the types of technologies that we could use to terraform the Red Planet. But after really understanding the desperate state of our own forests, I decided that if we're gonna terraform, we need here on Earth.
Reach remote areas. We need systems that can be automated. And we need systems that can scale, and scale fast. We believe the solution is industrial-scale aerial robotics, drones that plant trees. And today, we're here to show you that this is not science. It works in 2 phases. First, we fly over the land with our fixed-wing mapping drone, which takes detailed images, giving us information about nutrients, terrain, and biodiversity. We churn that data through a machine learning algorithm to generate. Second, we upload that planting pattern into our quad-rotor planting drone, which flies at 2 to 3 meters above the ground and fires a biodegradable seed pod at each predetermined position. The seed pod penetrates the soil, is activated by moisture, and contains all the nutrients for healthy tree growth. With 150 swarms of 6 drones cooperating together, we can plant 1 billion trees a year, with the potential to scale to tens of billions of trees each year, all at 10 times the rate and just 15% the cost of traditional hand planting. So let's show you how it's done. We first need to identify a site using satellite imagery and local knowledge, and then we come into the field. Our mapping technician selects the sensor type, the resolution, and the flight area to fit our operation. Once the flight path is set, it gets uploaded into our fixed-wing mapping drone and launched. As it flies over the land, image and thermal sensors. It can fly for up to 50 minutes, covering 12 square kilometers, with a resolution down to 1.5 centimeters per pixel. So what does that mean? It means you can see roads, houses, obstacles. You can see animals grazing. Now, when the drone returns to home, the data is downloaded and collated to generate high-resolution 3D maps. These maps are analyzed for unplantable areas, like this road, or these flowers, or these. The remainder is then analyzed with our machine learning algorithms to generate a set of precision planting patterns, which match the perfect species combination to each planting location to optimize germination and growth. Now today, planting teams are out there alone, but by collating data from all over the world, we are providing access to global knowledge. So now that we have our planting pattern, it gets uploaded into our quad-rotor planting drone. And today, our planting drone Macaroon, or casually known as Mac, is going to demonstrate that for us.
Let's get out into the field. All they need to do is load the seed pods and take off. Our engineers have optimized our planting mechanisms to be able to carry 300 seed pods at a time. And we aren't going to plant just one species at a time, we are going to plant 100 species at a time. By integrating our TK GPS and laser altimeters, we have the capability to navigate the most difficult of terrain. Onboard target acquisition system to match our plants. We can follow natural contours. Hardware and software, we can operate automated swarms. With a swarm of 6 drones, we are planting at 10 times the rate of the fastest hand planters today. We are not just leading the future, we are To achieve our goals of precision and high survival rates, in design for both the aerodynamics, but also to promote the growth. Fertilizers and seed pod materials have been combined with species that we are coating just in time for the seed pods to grow into healthy trees. Because we can't be everywhere, growth chambers to mimic the different conditions around the world. Testing in order of planting pattern. Now, healthy ecosystems, of course, require multiple species. So our biology team has been hard at work evaluating 1,300 different species already. And they have successfully demonstrated the capability to grow a number of tropical and boreal species that we've planted with this system in indoor and outdoor trials. We can plant these trees anywhere. And why are these seed pods so important? It's because these seed pods give the power to the system. These seed pods are the intersection between drone engineering and biology, which allows us to plant anywhere in the world, to grow a forest, especially to grow a forest where we need them the most. These drones are meant for planting. That's just what they do. We have created a fully scalable, fully automated, precision planting solution. Now, this drone today has planted nearly 40 to 50 trees in just a few minutes. Now, think about what a swarm of these could do at scale. In the last 24 months, we have been hard at work integrating our planting, mapping, and pod technology. We have validated our technology. It works. Now, all we need to do is scale. We are ready for the next step.
It takes more than just drones to plant 1 billion trees. It takes people with passion who can change the world. We come from 7 countries with 4 doctorates and deep expertise in drones, robotics, plant science, ecosystem restoration, and business development. We've assembled a board of world-class advisors from leading institutions like Google X. An incredible network of global partners who can help us put this technology to work and to make it scale. These include organizations like the Foundation, strong local community relationships to ensure that the seeds planted with our grow business model. We'll deploy our drones in impact on the Earth's atmosphere. By planting 1 billion trees, we will sequester 18 million tons of carbon dioxide each emitted from all the cars, productivity, and fresh water for the communities that need them most. Because clean water and available food, these are things that people will fight for. These are things that people will cross oceans for. Clearly, we are not just creating high-value tree planting jobs. We are creating an entirely new economy. The World Resources Institute has estimated that for every dollar spent on reforestation, an extra $2.50 is generated in local downstream income and benefits. So we expect to double the daily income of millions of families in the lowest economics brackets from around the world.
2 years ago, we asked the world to imagine a better way to plant trees. The future is here. To enable the future. By winning the Drones for Good competition, we will be able to increase our planting rate by 100,000 trees a day. That is enough trees that you can see them from space. That is enough trees that we will be able to start to reverse these destructive trends. We will be able to towards a more peaceful, more sustainable Earth. My name is Dr. Lauren Fletcher.
And my name is Dr. Susan Graham.
And we at Biocarbon Engineering invite all of you to join us as we change the world 1 billion trees at a time.
All right. All right, there you have it, our first team in the international category of drones for good, and that is Biocarbon Engineering with a great presentation over there. As we get our next team set up, the next team set up is Drones for Right to Life. Shaban's over here, our drone expert who's been with us for the last 2 years. Shaban, what can we say about this team? I believe it's a returning team. I'm sure I've seen them last year, right?
Yes, they were last year, and they had a bit of a malfunction with one of their seed deployment pods, and they've actually changed their design. They've improved it. That little noise that you were hearing with the sound of the seed pods being fired. And from my understanding, from talking to the team, talking to their leader, Lauren, it was because the seed pods need to penetrate the ground so that they're there and they're not just sitting on the surface. And that's
welcome to our audience. Part 1, which we're doing the International Drones for Good Awards later on. Winners and hosting our award ceremony as well. The next team to set up is Drones for Right to Life. Shaban's got some information about our next team. Let's tell you what to expect next without spoiling too much, of course.
So, Drones for Right to Life are actually trying to solve the migrant crisis, and they want to have a sort of a permanent monitoring solution out in the oceans that is looking out for refugee boats so that they can be assisted before We've had a lot of humanitarian issues, obviously, because of the political climate. And they're tackling that problem with two types of drone solutions. One is an unmanned aerial vehicle, and they have a little bit of a unique second vehicle, which is the ASV, an automated surface vehicle. And you'll see that probably during the demonstration. It's basically this boat that is completely automatic, and its role is to allow the drones that are flying to support it. So it will act as a mobile charging station, mobile ground station, so you have radio ranging environment, and you need that kind of support. You can't just, but there's no ground, there's no island to work from. That's why they have the boat.
Great. Also, thank you to our judges who are sitting nice and high up in the grandstand. They are judging the competitors on the following points. 50% of the points they're getting is on service and technical evaluation, which is preloaded. 15% on their on-site presentation, on their on-site demonstration. All right, there are 8 judges per category who will base their decision on these 2 on-site graded criteria. Your chance to win.
Name, your email address, and your phone number, and then you should be entered into the draw.
And this is not just any, but as far as maybe
portability,
and also something that everyone can use. So it's a great drone. If you want a chance to win that, make sure you log on to the website. And don't forget our social media hashtag as well. If you're on the social media, hashtag UAEA4G if you're posting those pictures up on your social media accounts. All right, just a few moments before our next team rolls in. Let's tell you who else to expect today. All right, I think we got the thumbs up and they're ready to go. We'll tell you about the rest of the teams a bit later on. Now, please put your hands together for team number 2 in International Drones for Good. This is Drones for Right to Life.
So, we are Drones for Right to Life. We came from Portugal. Just to let you know a little bit about our background, we are we are part of a research institute. We are a research group inside the institute, and we have working together for like five years now. And the foundations of the work you are seeing now were made in the parking lot of the university and in the backyard of one of our colleagues, because we didn't have enough resources at the time. But we started a couple of colleagues. Now we are a large group of friends, and we evolved. And now we want to help with our societal problem. Okay. This problem was fortunately also addressed from other teams, because it's a very important problem. And I think the scientific community and the technology community is eager to solve it. As you all know, 100 persons died, while with around 42,000 persons dying trying to cross the Mediterranean, fleeing from poverty or war. Okay, despite the routes, or the most usual routes around the Mediterranean are known, it's very difficult with the current methods to cover all of these routes. This means that lots of boats are missed and lots of people drowned because of it. So we wanted to try to solve this problem, and we devised the concept to do that. Okay, so this is a small video that describes the concept. Our concept is autonomous teams of a boat and several UAVs that survey the sea using a kind of movable sensor network. They perform patterns on the sea and try to find salient objects. From high above, they can see the salient objects and then try to make sure, or to assure, that there's a migrant or a migrant boat. If that's the case, all other teams to try to life rafts, inflatable rafts, to buy enough time for traditional rescue operations to arrive. This is extremely important because this can allow the migrants to live long enough until rescue. So now we are going to start our demo. This is our scratch from us. It weighs around 8 kilograms. It's from carbon fiber, and it was designed to So now the drone is going to fly over the lake to simulate a search. And this search would try to find, with his inboard camera, salient objects. Starts to move towards the center of the lake. Okay, and try to make a type of search pattern. That's not a problem. It's designed to land on the water. And I don't know if you can see on the feed. Yeah, you can. It can even move in the water. That we can use and exploit a phenomenon called ground effect. If we move, we don't need as much as energy as usually. This is only done to move the drone from one place to the other, to repositioning it for the large survey operations. So now we are simulating, again, a survey. The drone goes high to the sea and try to find, and when the drone reaches near the migrant ship and a confirmation from a remote operator is achieved, that is indeed a migrant ship, it lands near it. It lands near it and starts an emergency beacon to all other distress and search and rescue operations to converge to that area. So now the migrant ship was found, and the autonomous boat will move towards the area. Okay, so now the boat goes directly to the GPS position of the UAV, of the drone, that is a UAV, okay? And other drones that can use the boat as shelter or to replenish its energy can take life vests or life rafts faster than the boats directly to the migrants. Here we are simulating, as this is a small lake, very near, but this is designed to withstand longer operations. Okay, so basically this is the main idea. We want to have a large network of smaller amount or number of boats. Okay, so that is not a problem also, because they are designed to be cheap enough to be lost. That's the main idea. If you have a manned helicopter, you spend a lot of money. If they, for instance, have a problem and remain at sea, you lose a fraction of the cost. So our idea is to have a permanent network and place it on strategic points in the Mediterranean to be able to find migrant ships and perform first aid and first response. And so
Very impressive. And you have to understand that they're operating 3 UAVs in a very confined area. And I was a little worried. I'm like, wow, that thing's going to drop out of the sky into the water and then flew off the water. I think it's the first time in the show we've seen that happen. Usually the drones that get into the water don't actually come back.
That's true. And when it actually took off, I was super impressed on how they did that. And a great presentation over there from Drones for Right to Life. All right, getting our next team set up on stage, and that is Forefront Robotics. I believe another returning team this year.
Yes, Forefront is coming back. They're coming to us all the way from Canada. And they have 2 drones for us today. One is a very ultra mobile twin rotor solution, which is a bit like a helicopter, probably one of the more unique designs over here. And the second one is a tricopter, and they've been working on this for quite some time, from what I understand. In year 1 of the show, when they were here, we just saw 3D renders of what they wanted to do, and they actually have one of those drones here now with us.
Excellent. And also, let's thank our sponsors real quickly for making this event possible. A big thank you to Dubai Internet City, the leading sponsor, event partner Do, Samsung and Digi Robotics, and community partner Makers Builders. Not forgetting the TRA and ICT Fund for putting this wonderful event together. Day 2 here at the For Good Awards, and the sun is shining on this beautiful day. We have lots of great teams coming up today, so make sure you get those cameras ready. Make sure you take some great pictures, and if you are posting on that social media, don't forget hashtag UAEA4G. That is the hashtag for today. I saw some hands up in the air when I said the sun came out. I think nobody was expecting the sun to come out today.
No, it's been quite an interesting morning. I was driving up to the venue and it was raining. I was like, wow, this is going to be a little bit of a challenge, but gods have smiled on us and the sun is out.
I actually spoke to Amar earlier. He told me to always be optimistic and everything will work out. And I guess his words were heard. All right, we've got a couple of, maybe a couple of more seconds for the next team to set up, Forefront Robotics. We actually have a visual of what they're presenting up on the screen next. So this is the helicopter.
Exactly, this is what I was talking about. So this 2 years ago was a render, and now they have actually produced it. It's a twin rotor in the front, and there's a small rotor at the back with pitch control, so that's essentially a tricopter.
Wow, fantastic. All right. I've been told that their time is up for setup, and we're going to give them the cue to go. And here's team number 3 at the International Drones for Good Awards. Ladies and gentlemen, please put your hands together for Forefront Robotics.
Over to you. Good luck.
All right, well, thank you, everyone. We are Forefront Robotics, and we are from Canada. We're a small team of engineers who specialize in designing robotic systems for use in confined spaces. And we're here today to show you an aircraft platform that has capabilities like no other aircraft you've seen. So every year, there are hundreds of thousands of call-outs to search and rescue teams of fire, police, and emergency services worldwide, year-round. The 21st century presents unique challenges to disaster response. Our team is tackling these challenges by developing an aircraft which can assist in relief operations in complex natural and urban environments. According to the UN Population Survey, nearly all of the world's population growth in the next few decades will take place in urban centers in low and middle income countries. This puts greater numbers of people at risk of natural disasters such as hurricanes, tsunamis, earthquakes, and other non-natural disasters such as industrial accidents and explosions. The average natural disaster frequency per year is 384 natural disasters per year, and this number does not include non-natural disasters, like building collapses and explosions, which happen for other reasons. Increased urbanization makes natural disasters more potent by putting more and more people in a smaller target area at risk. In 2011, for example, natural disasters caused an estimated $366 billion in damage, economic damage, killed over 30,000 people, and injured a further 244 million victims. There don't have to be this many casualties. At Forefront, we're passionate about developing drones that will reduce these numbers and save more lives. All right, I want you to take a second and imagine yourself as a first responder. You've just arrived at the scene. There's smoke and ash hanging in the air. You can't really see what's going on. You have fragmented reports on the situation. What you need to do is you need to get into the accident zone. You need to move around, collect data, identify the hazards to both yourself and the potential victims in the area. What you need to do is make a plan, and what you need to do that is the Navigate. Our aircraft is a series of highly maneuverable vertical takeoff and landing aircraft designed to be used in helicopter impenetrable environments. So what is a helicopter impenetrable environment? Well, this would be anywhere where it is unsafe to send a conventional helicopter or exposed rotor vehicle like a quadcopter. So below tree cover, through city streets, into a mine shaft, into a collapsed building, things of that nature. The Navigate is designed to be easily deployed, and it's a scalable solution, meaning that the same capabilities in a small aircraft like this can be put into an even smaller aircraft or scaled up to a much larger aircraft. So how does it work? The designs for the Navigate have two ducted fans which flank a central hybrid composite fuselage. The ducts can pivot back and forth on their axis, allowing for the vehicle to perform various maneuvers. The ducted fans both protect the rotors as well as increase the thrust efficiency, making this a much more user-friendly drone as it increases the payload and flight time. So multiple payload spaces are built onto the airframe, allowing many different types of sensor packages and payloads to be used. Sensors that not only detect the area around the aircraft, such as a spherical LiDAR or a spectral camera, but also the ability to detect the status of victims within the target area and the disaster zone, and send that information back to search and rescue teams. So the Navigate has been designed with customization in mind as well. Things like a ballistic parachute, different types of landing gear, different types of sensors can all be easily swapped in and out through our designs. So the aircraft is also equipped with a tail rotor. And what this does is provides for the maneuverability, allowing it to penetrate confined spaces. We're going to get more into that later. So all of these features combine to make the Navigate suitable for a range of modern search and rescue missions. But it also allows the aircraft to be used for many different types of missions, including mapping, environmental assessment, or infrastructure assessment, and potentially oil and gas pipeline, inspection. That kind of thing is completely within the capability of this aircraft. So we're going to come back to that idea of maneuverability. We've developed software for the Navigate, which allows it to hover while pitched. This vastly improves its capabilities and is something that no other aircraft can do. So what you're seeing on the screen when it gets back to the last slide, there we go, is the pitched hover. It's a simulation on the screen, but what it would allow the aircraft to do is land on a sloped surface. Additionally, we can also land and take off from a ship that is rapidly pitching in rough seas. All right, so we brought our latest prototype with us to demonstrate the capability of the pitched hover. So as you can see now, the aircraft is holding a steady, level state. It's very stable, reacts very well to disturbances. However, if Frank was to command it to go to a different angle, it will go to that angle and hold it. It's still just as stable in this attitude. as it is in any other attitude. These angles right now are being commanded by Frank. However, the autopilot can very easily determine what angles may be needed for a given mission. Additionally, we can take off of a surface on a slope without actually telling the aircraft that it's on a slope. It detects that, and once it takes off, it automatically finds its level and starts to maneuver. Thanks, Frank. So the other thing that we've developed is software to allow the aircraft to maneuver through environments. What you see on the screen is a simulation of the aircraft maneuvering through a cluttered environment in an autonomous mode, using the pitch hover to effectively navigate through the environment. All right, so remember when I said earlier that the system is designed to be scalable? The system is also designed to be platform independent to a degree. What this means is that the same navigation and obstacle avoidance protocol that guides this aircraft can be applied to an underwater aircraft or another watercraft like this, which we are also working on development. Basically meaning that you can utilize this system in many different environments, all used by search and rescue, but also used by many different other potential customers. All right, so the Navigate is not only designed with hovering in mind, but we've also designed it to transition to high-speed forward flight. So when it's flying in high-speed forward flight, the ducts here, if it was flying in forward flight, would be angled like this. And ducted fans, which are designed in the way we've designed these, actually generate additional lift in forward flight, which means that we can fly further than if we simply had an open rotor. All right, so we're going to demonstrate a mission to you using a vehicle very similar to the Navigate. It's actually something we've used to develop some of our software that's in the Navigate. So this vehicle is able to pitch hover. However, you'll note the lack of a tail rotor, which means that it can't do it quite as precisely or effectively as the Navigate can. But we're going to demonstrate to you how it can and how our system can be applied to multiple vehicles. So as you can see, Bicopters can maneuver very stably and very effectively. So putting it into the pitch hover, and like I said, it's much more difficult with only the two rotors. However, it can be done. So a search and rescue team would deploy the vehicle and command it to go off to the site. Now I want to tell you something about when this aircraft is in forward flight mode. It actually can go very, very quickly, up to 200 kilometers per hour. So in this small area, we're not going to go into a full transition. It's just too small and too dangerous. However, when the aircraft transitions into its high-speed forward flight mode, it uses the exact same control systems as when it's in a hover, meaning the variable pitch on the fan blades and the tilting of the ducts. That's what is actually guiding the aircraft through the air in forward flight and hover mode. This means there's a single robust control system in use. So the other part of that is that we don't have conventional control surfaces as you would on most transitional vehicles. So there's no ailerons, there's no elevators on this aircraft. There's just control surfaces, there's just a stabilizer surface, and that's it. All right, so when the vehicle was come back from the mission, or when it was at the mission, it would utilize the pitch hover, as you've seen it doing above us, quickly come back to the landing zone and relay all of the information is gathered to the search and rescue team. So if the aircraft was commanded into a GPS or communication denied structure, the drone would collect data about its surroundings, navigate the space, and actually return to the users having found data about the victims in the area, the potential hazards, as well as the physical environment itself. The Navigate is capable of using its sensors to generate a map of the area and deliver that to the search and rescue responders should they need it. So as I said earlier, we couldn't transition the aircraft fully. However, on the screen, what you're seeing here is the aircraft going into its transition to full high-speed forward flight mode. And you can see once you get the rotors tilted straight over, it actually takes off very quickly, like I said, about to 200 kilometers per hour, which allows search and rescue teams to get the aircraft in, collect the data they need, and get it back. So our goal at Forefront Robotics is to use this technology to significantly reduce the number of casualties in urban and other disasters. Remember those figures, 244 million victims? The Navigate can help to reduce those numbers by making search and rescue teams as effective as possible, allowing them to save as many lives as possible when disaster strikes, and disaster does strike. Thank you so much for your attention. That's it.
There you go, the third team presenting in the International Drones for Good. That is Forefront Robotics with the highlights on the screen right now. A returning team this year. And this one doesn't really look like a drone. So is this still a drone? It looks more like a helicopter.
Well, if you actually want to talk about the term drone, a drone is essentially anything that you can put an automated flight controller in and you can get it to do, some sort of automation, right? So this traditionally would be, yes, a bicopter, and it has got a helicopter design, but it's got a custom-built flight controller, custom code that they've been developing for this type of system, and it's completely automated. You can fly this off a laptop, fly it over long range, and yeah, that's why we've been having this debate about what is a drone and what is not a drone. Some of the stuff that you find in Dragon Mud, that's not really drones because it's just a simple flight controller, which is just a barometer and accelerometer and no intelligence. So something with intelligence, a drone. Anything with no intelligence, quadcopter, basic RC toy.
Right. Speaking of anything being a drone, you should see what's making its way to the stage right now. I mean, this is something spectacular. I've been watching this down here at the pit. It's our next team who's presenting it, and these guys are called Avy.
Avy.
Avy
have come to us all the way from the Netherlands, and their lead is Patrick. I was having a chat with Patrick. This is one of those drones which is also designed to tackle the humanitarian crisis. And we're going to see a common theme here. Any drone system and any team that's trying to solve humanitarian issues, one of the big problems you're going to have is range, because if it's a conflict area, you want to fly as far away from it, or at least take off as far away from it as possible, and then get the drones in there so you don't have to have humans there. If it's over the ocean, again, range is really, really important, and that's what these guys have tackled with their design. It's a very unique design. It's the first time we have seen a boxed wing design over here, and this is a hybrid VTOL, so it's part aircraft, part octocopter. Actually, it's an X8 configuration. Again, it's quite complicated to build one of these things, and hats off to the team for coming up with it. It's also the fastest drone we have over here. I believe it can go up to 200 kilometers an hour, and that gives it a significant amount of range.
Excellent. All right, just a few moments before they're done with their setup, and we're going to give them the cue to start presenting. So all the teams getting 12 minutes to present today, and 2 minutes to set up. All right, we're ready to go. We got the thumbs up from the guys on stage. Here is team number 4, International Drones for Good. Please put your hands together for Avy.
Hello and good morning. It has been a great couple of days because here on this event is where true innovation is happening. And the last couple of days I've been meeting up with the other teams, and I'm really, really impressed of together all the things that we can do. I really believe that what's happening here is actually what's going to happen in the future. We are shaping the future here. So really, really great. So my name is Patrick, and I'm the founder of Avy. And I'm a man on a mission. Because not that far from here, there are people dying. I want to rescue these people and save their lives, but I need your help. About 2 years ago, I first heard about the refugee crisis on the Mediterranean Sea. I read it in the newspapers, heard it on the radio, and I saw the images on television, and it literally shocked me when I saw what's happening there. Apparently, 4,000 people die there every year. 4,000. And I just couldn't understand why no one could do anything about it. Because it happened then and the year after, and it's still happening even today, even right now. I couldn't understand, so I decided to act. This is the situation. Due to war, hunger, simply extremely dangerous situations, millions and millions of refugees flee their home countries to save their families, their kids, and their lives. And this is hard, because imagine if we had to leave everything. Many of the refugees cross the Mediterranean Sea. They have to, and this is an extremely dangerous part of their journey. Due to the flimsy boats, the overloaded boats, many people will drown. Most of them cannot swim and will not make the journey. And I cannot, and I know that you cannot either. There are three things necessary. First of all, we have to know where the refugee boats are, right? Second, we have to make sure that we get there as quick as possible whenever the boats are in need. And third, we have to bring them something. We have to give them something to literally hang on to, because those people will drown. They cannot swim. And then it's very important that we can broadcast their location to all nearby vessels, to fisher boats, rescue services, helicopters, etc. We have to make sure that their location is known. So, I first thought of drones. Could drones maybe solve the situation? But I soon found out that drones were absolutely not good enough. Their flight time was too little. All the drones can fly 20 to 30 minutes. Not good enough. Their range was too short, usually a couple of 100 meters, sometimes maybe a kilometer, but that's about it. Not enough. And they cannot bring rescue gear. So I knew that all the drones that were available were absolutely not good enough. So I also knew something radically new has to be invented. Over the course of the last couple of years, we have been working day and night on a solution. I've teamed up with the most brilliant engineers, the technical universities, the Dutch Aerospace Lab, and even the European Space Agency. And with almost no money, we worked day and night together, because we knew that this could be the change maker, and we knew that we all believed in this. So, ladies and gentlemen, today, on this morning, I'm very proud to finally show to you Avy. Here she is. Avy is the world's first aircraft that is here to rescue thousands and thousands of lives. Avy is a fully self-flying aircraft with a range of 400 kilometers, with a top speed of 200 kilometers an hour, with 0 emissions, a payload of 10 kilograms. She will do the job. We named her Avy. Avy is fully self-flying, so we also developed a ground system. The ground system makes the whole system of Avy plug and play. And Avy is able to take off vertically as well as fly horizontally. Therefore, Avy is not a helicopter, it's not a drone, and it's not an airplane, but it does combine the best of these three worlds. Avy takes off vertically, then flies horizontally, and the engines, they tilt very smoothly. So instead of a tail flight or something, this happens very, very smoothly. And then in forward flight, it will be 10 times as efficient as any other drone, making sure that we can fly 4 hours instead of those 20 or 30 minutes, making sure that we have a range of 400 kilometers. Well, let's see how that looks like. So as you can see, Avy is meant for long-range flights. In here, it's quite small, it's quite windy. Therefore, we're not going to fly out of this area and not further out because of the wind gusts. Avy, what you see here, has two options. It's built very modular. That means that we can use it in forward flight and also in hover flight. Avy, apart of the fact that it's self-flying, is also very cost-effective. For the cost of one rescue helicopter, literally 170 Avys can be acquired. Therefore, a whole fleet of Avys can patrol the Mediterranean Sea 24 hours a day, 7 days a week, day and night. And whenever we fly over the Mediterranean Sea, we can make sure we can detect a boat. We made an automated boat detection system with a built-in visual camera and a thermal camera for night vision. Therefore, we can detect the boat and we can send this information directly to all the coast guards so they know what's going on. Whenever there's a boat in trouble, we know where the part is and where they will probably go, and we can decide to act and rescue. We developed a specially rescue device. We can drop medicine, live vest, food, water, everything, but this rescue device is something special. Here, my colleague Paul will show you what it looks like. We can transport this over the Mediterranean Sea, and whenever we want, we can drop it. Whenever it touches the water, it will automatically inflate. What will happen is that when this rescue device inflates, whenever in the water, it will go up, form a flag, form a rod, and inside, up here, is a built-in transponder. It's up the water, so it will automatically transport its location. It also has a built-in speaker. The speaker will help the people to stay calm. So, this device makes sure that we know the location of the people and that we can broadcast the location to all nearby vessels. This transponder and the coordinates will also be sent to fisher boats in the area, so also the people nearby will know that there are refugees in the water, and we know for sure that these refugees can and will be saved. Then, after its rescue mission, Avy will fly back home to be reloaded while the rest of the fleet continues patrolling. As you can see, Avy is built to be a lifesaver. It's built to patrol the Mediterranean Sea, know where the boats are, rescue them, and make sure that we save thousands of lives. But because we developed Avy to save lives, it became such a technologically advanced aircraft that it outperforms every other drone. Therefore, there are many more applications feasible. Think of, for example, wildlife protection, saving our planet's precious animals, making sure we get the poachers in time. Or what about first response missions, because we can fly that long and that fast. Or think of police, because with a flight time of 4 hours, you can literally stay up in the air and survey for a very, very long time. Disaster support, earthquakes, tsunamis, you name it. This aircraft does it way longer. Professional inspections will also be perfectly feasible. Ladies and gentlemen, this is Avy. It looks different, and it's a one-of-a-kind, unique aircraft for long-range flights, top speeds, and extremely long flight time. Avy is here to improve the quality of life, work, and to save thousands and thousands of lives. For now, we ask Drones for Good to support us, so that already this summer, a fleet of Avys will patrol the Mediterranean Sea, find the refugees in need, so we can save their lives. It's time to act now. Thank you.
Yeah. There you have it, our fourth team. That's Avy with a great presentation over there. Highlights on the screen right now. A little unfortunate that they couldn't get the drone to fly a little higher, but nevertheless, a great presentation over there. Just a few moments before they clear the stage and we get our next team to set up, and the next team set up is Skycart. But let's talk about what these guys are doing over here.
Yes, you did say it was a bit unfortunate, but you have to understand that, first of all, hybrid VTOLs are extremely, extremely hard to pull off because you're trying to solve the, you're trying to have an aircraft that can transition, and there's so many problems, engineering challenges involved. And I know Avy have been working really, really hard. A lot of last-minute decisions they were making over here while they were on site, and it's quite a large drone. When you fly these devices, generally you fly them in a really large area, so. It is a bit of a challenging environment to fly in, but nevertheless, mistakes do happen, and that's just part of the show, and it's a learning experience, and you learn from it as an engineer, and you move on. Let's talk a little bit about Skycart. They're our next team to come up on stage, and Skycart is working on a drone delivery solution, and they're the only team over here that are actually displaying drone deliveries for commercial use, for logistics, right? And this is a big talking point in the world right now. We know that Amazon is working on drone deliveries. Google at one point were working on drone deliveries as well. And it should be interesting to see what they have in store, because delivering packages is relatively easy. A lot of people have been doing it, but doing it every day, day in and day out, on the kind of level that you expect from FedEx and DHL, that's quite a different challenge.
I'm wondering if they can deliver that 75-inch TV that I ordered last week. Would that be something realistic in the possible future?
I think in the future, maybe if we have a small, we can order off souk.com on our cell phones, and we order pizza that shows up in 30 minutes. Imagine packages that show up at your doorstep or on the top of your building when you buy them, and they show up in the same time frame as a pizza.
That's a good idea. Maybe something for next year.
Yeah, something for next year. Maybe we will see that in the near future, in the next few years, as drone regulations become more conducive for drone deliveries.
All right, welcome to all our audience here today on day 2. Just a reminder again that you can log on to the website a4g.ae and you can vote for your favorite team. Could be your friends, your family, or maybe a team that you really like. And by voting for them at the People's Choice, you can give them a couple of extra points to add on to the points they're getting from our judges. 8 judges per category today, and they're basing their decision on 2 graded criteria today. 50% of the points were received preloaded for service and technical evaluation, and 15% on on-site presentation, and 35% on their on-site demonstration here today. And of course, thank you to all the sponsors as well. Dubai Internet City, as always, for the great venue. The event partners do Samsung and Digi Robotics, and the community partner Makers Builders. Not forgetting the organizers, ICT Fund and TRA as well. So we're getting close to the halfway mark with our next team. Will take us right to the halfway mark, and then we will begin with the next set of teams. And just to let you know who's going to be expected today, we have Aerial Robotics, Lab Spider Drone, Twing Tech, Nokia Saving Lives, Wingcopter, and Minekafon.
And we've just received the heads up from the organizers. We're good to go. So Skycart, whenever you're ready, we can start.
Your Excellencies, ladies and gentlemen, welcome to the future of deliveries. My name is Lucas. I'm the co-founder of Skycart. And in the next 50 minutes, I will be happy to guide you through our presentation here at the Drones for Good Award in Dubai. So my team and I, we are so proud to be here to show you what we've developed in the past 3 years. But before we start, I will take you on a quick journey to demonstrate and to explain what motivated us to build Skycart. In the meantime, my team will set up the operation. So what you see on the screen, that's me. 3 years back in the Austrian Alps, I went hiking with a friend. It was a beautiful sunny day, and our goal was to climb to a mountain peak 2.5 kilometers. And we already reached the snow line after 3 hours, but we had 2 more hours to go. So this is how the snowfield looked like. It was a beautiful view down to the valley, but then something happened. I didn't pay attention to my foot, to my next step, and then all of a sudden I sprained my ankle. My foot was hurting, and I couldn't really continue the ascent, nor could I go back to the valley. So my friend and I, we discussed what to do. We came to the conclusion that an ambulance helicopter flight may be way too expensive. So the only option we had is that my friend had to go back to the valley to get a splint for my leg. That would mean I had to wait there in the snowfield, and that's what I actually did. I waited and waited for hours. So that was not a good day for me. But it gave me time to think about, this unpleasant situation. And I thought about the disadvantages of a helicopter flight. So what we see here is a direct comparison. If we use a helicopter, it would cost several thousands of dollars to come to my location in the mountains. At the same time, the operation would have been limited to daylight flights only, because helicopters usually operate only at daylight. And it would take a certain amount of time, at least 30 minutes, because the crew has to prepare for the flight, get to the helicopter and get started. Isn't there a better way? Isn't there a better way to, instead of paying thousands of dollars and waiting for such a long time? And that's how I came up with the idea of using drones for deliveries. I thought, why don't we use like a cart in the sky, or we call it Skycart. That would be a great solution, a drone that could deliver something immediately to my location. It would cost probably only a few dollars, right? You have the drone, and if you click on a button, the drone comes to your location. It's not that expensive. So that's a clear advantage. And another advantage, obviously, a drone that is self-flying could operate around the clock. So another clear advantage. Also, it would be probably much faster than a helicopter. A drone doesn't need to be prepared. It stands on the ground, you take your mobile app, you press on a button, the drone gets started and flies to you right away. So this would have been a solution, I thought, and when my friend returned to my location, I told him and he was excited, and that's how Skycart got started 3 years ago. So before we start our live demonstration today with this drone, I want to explain you a little bit about our UAV. So what we have here, this is a hexacopter model. And the cool thing about Skycart drone is that we can handle almost any kind of package size. That is very unique. No matter if you have a small box for medication, or you have a medium-sized box for pizza, or even a large box, it doesn't matter. We have a patented system that is able to grab any box of any size, so that's very cool. Besides that, we can lift up to 5 kilograms. That's enough to ship 88% of all goods that people typically, usually very urgently. So this is about our specifications for the payload. On top of that, our drone is designed for last mile deliveries. So our goal is not to go long distance, for example, from Dubai to Abu Dhabi. Instead, we want to serve people or businesses who need something urgently, for example, in remote areas like the mountains or in the city area of Dubai. Our drone is able to fly up to 40 minutes, and that's enough to reach any corner of the city. Always remember, fly the direct route. That means we are up to 6 times the route of the drone is up to 6 times shorter than the route of a car. For example, if you go from here to the palm, we can go straight. A car has to follow routes. So that's why we are faster. The other thing is, and that is the magic behind Skycart, our system works completely autonomously. That's what you see here. It's already developed. Our drones always fly and only flies without people, without pilots, without operators. All you need is a mobile app. You log into that mobile app, then you press a button in order to select the destination, and then you are ready to go. That is exactly what we will demonstrate here. It's our secret sauce, and that's why the operation is so efficiently, because if you do not have any people who need to handle the drone, you save a lot of money, and you're more flexible. Remember the 24-hour operation. All right, so let's do the next step and give you a live demo. What we will present to you today is a delivery of a package. As you see, the package is already attached to the drone. We will take off, and during that flight, I will give you some information about the flight itself. So the team is just preparing the mobile app. We want to show it as it actually works. So probably a few words to my team. We do have operator and backup pilots here, but this is required by the organizers. So just in case, they can take over. But as you will see, the drone flies itself. It's a self-flying drone. Okay, ready to go. Okay, so a quick explanation. I see here the map of Dubai. I see our location here in the internet city of Dubai. And the drone is located on stage. All I have to do is to press a button to get started. One second. Start from okay, probably it's not turned on yet. Okay. All right, I'm set here, and we just plug it in again. And then we take off. We fly a short circle over the lake, then return, and then we want to deliver the package here live on stage. All right. Simon, I'll... Can you do it manually? Oh, yeah. Just gotta reconnect. Oh, okay. We just try connect to the drone. Probably a few explanations about that. What we have is the drone, and we control the drone via a mobile app through our Skycart platform. And the platform, that's a software system which allows us to run one or multiple drone operations. For example, if you are a drone operator and have 5 drones in your place, then you can run all of them through our Skycart platform. All you need is just one app. You log in and you get started. Okay, here we go. I press. All right, the motors are spinning, and now the drone is ready for takeoff. See my finger? I press the start button like on any other mobile app, and we are ready for takeoff. The drone takes off vertically, and then it follows a certain flight path over the lake. Okay. The package has been dropped a little bit early. That shouldn't happen, actually, but I will take it. And now it flies a short circle. It's a little bit windy, gusty over there. And then the drone will return and land here on stage. Again, this drone is flying autonomously. And it tries to balance, of course, the wind. So if it's shaking a little bit, that's all right, that's normal. It tries to hold the position. Okay. Now it returns. Okay, bring it. Okay. Now the drone comes back to the stage. And we'll drop off the package. Right. So all of the flight was autonomously. The challenge for us is, of course, always the wind, so we try to balance that. Some technical information, we use GPS for the general flight. We have a precision landing system to identify the landing points. And this system will be used in different cases. So what we have done in the past couple of months, can I have the presentation back, please? we tested this in different areas. We went to Switzerland, tested it with Swiss Post over a couple of weeks. You can use it for emergency aids, you can use it for roadside assistance, and you can use it for even for job site delivery. So for everything that you even imagine. It doesn't matter. You can use a carbon-made box. It doesn't really matter. So at Skycart, we aim to build the future of logistics together with you. We want to make autonomous deliveries the standard in the world because it's much more efficient for everybody, for the businesses, for the recipients like the consumer. This is the future. And we want to build it together with you here in Dubai. Thank you for your attention.
That was Skycart, our 5th team in the international category of drones for good, with the highlights on the screen. And I was just mentioning, you know, if I was having my TV delivered, I would have dropped over there at the beginning.
Yeah, it was a small TV, so it didn't sustain much damage, so don't worry about that.
All right, a delivery system which can work great. You know, the way we order things online these days, having a delivery system like that can just speed things up. So, you know, the second you want to buy that mobile phone or something from Amazon or Souk or any of the other websites, it comes to you a lot quicker. And as you mentioned as well, it could be something quick like a pizza as well.
I think so. I think that's the kind of time frame that we're in that age where consumers expect that kind of time frame for deliveries for food. So if you're putting drones, for packages. So if you're putting drones into the equation, they may probably want to see that sped up from like 2 to 4 days to like a day, maybe a couple of hours. And that's where all the companies will be competing as who can do it fastest.
All right, great. All right, we got a couple of minutes for the next team to set up. The next team coming up is Aerial Robotics. You also have a few minutes to grab a refreshment if you like. So if you want a few minutes break, you could take that break now. And once again, next team coming up, Aerial Robotics Lab Spider Drone, followed by Twing Tech, followed by Nokia Saving Lives, followed by Wingcopter. And the last team in the international category today will be Minekafon. And then, of course, we have our national category of drones for good. And later on today, our awards ceremony coming on to announce the winners of the big prize, the $1 million prize in the international category and the $1,000,000 dirham prize in the national category. So we'll be back in a few moments. Don't go anywhere. Ladies and gentlemen, welcome back to part 2 of our International Drones for Good Awards. And we're ready for our next team. And the next team who's going to have 2 minutes set up is Spider Drone Aerial Robotics Lab. And while they have their 2 minutes to set up, let's have a chat about what to expect over here. Now, Shaban, you've had a chance to speak to all the teams over the last couple of days while they were rehearsing. So what are these guys doing?
So Spider Drone, the keyword here is Spider. One of the big problems we have in the drone industry is the battery life is a bit of a limitation. Everyone is fighting that. So you want your drone, no matter what payload it has, you want it to stay up for as long as possible. There are different ways people are trying to solve that problem. Spider Drone's solution is to create a drone that is a bit like the spider. So it has these, and it's able to hang from objects, to put it in a very, very simple way. And that allows it to stay on for not just hours or days. It can stay on, I believe the M600 that they have, it's got a standby time of up to a week. So you could put a camera on one of these things, perch it up on top of a tall tower, and it'll be able to operate for a very, very long time.
And if I'm not mistaken, I'm seeing a drone on top of a drone there as well. So this could be pretty interesting over here what these guys are doing. All the way from the UK today, it is International Drones for Good Awards. National coming up a bit later on. If you have just joined us, welcome. Don't forget to vote for your favorite teams today for the People's Choice Awards. You can log on to the website on a4g.ae. You can also try to win a drone of your own today. We actually have 2 to give away. All you have to do is log on to the website to go and register. And the website to register is awardsforgood.ae. 2 DJI Mavic Pros to be won. And I can tell you, it's one of my favorite drones that are out there from the reviews that you hear. A very good sized drone. And I think not too hard to fly. If you're thinking about getting into drone flying, this could be a good entry-level drone for you.
Yes, and if you are looking to get into drone flying, we'll have a bit of tips for you later on during the show. I'm sure that a lot of our audience are looking at these amazing devices and they want to head out to try and get one and try and get into flying one. And so stay tuned during the show. We will talk about the drone regulations a little bit in Dubai and give you a little bit of advice on how to get started.
Also, thank you to our 8 judges here today who are grading these guys based on the 50% service and technical evaluation, which they preload, and another 50, which is happening right now during their presentation demonstration, 15% for their on-site presentation, and 35% for their on-site demonstration. Never an easy job for the judges. However, we do appreciate their presence over here. Thank you for being here with us. Best of luck to the judges too, and of course a big thank you to all the audience who's here on this beautiful is ready to go. And to be fair to all the other teams, everyone gets the same time to set up as well as the same time to present. 2 minutes to set up, 12 minutes to present.
And just a quick reminder while we're waiting for our team to set up, we've got about 9 national teams to go right after the international category is over. We've got the Sun Academy coming up, Drones for Search and Rescue, Firefly, IntelliDrones, Customizable Drones, Saeed, IORTA, Find a Drone, and East Hawk. And these are our national teams. These are drones built right here in the UAE by university students, by entrepreneurs, DIYers, and so do stick around if you want to see some of these projects in action. Just received the heads up from the stage. They're good to go. So over to you, Spider Drone.
Assalamu alaikum. Good morning, everyone, and thank you for being with us today. Now, we believe that to do the dangerous tasks and to improve their quality of life. At the Aerial Robotics Laboratory at the Imperial College in London, we developed this next generation of drone, a generation of drones for the good of humanity that will be able to do these tasks. Let me tell you a few things about future cities. First of all, there will be 3 billion people moving to the city in the next 30 years. Because of that, the construction industry is currently about $5 billion per year, but it will double over the next 7 years. Now, why am I talking about the construction industry? The construction industry is one of the most dangerous sectors in manufacturing. It is driven by huge needs for speed, cost, and high quality. Because of that, we have 1 fatality every 2 minutes. Now, and 50% of that is by falling from heights. So working at heights is really dangerous. Now, 1 per 2 minutes, this is 30 per hour, 720 per day, and more than 260,000 per year. Now, this number can be reduced, and the industry needs technologies to improve that, to address this need for this very dramatic effect on the families and on the construction industry. Now, drones have an important role to play in that. However, drones are not there yet. They're not ready to help in that. Today, drones are just used for aerial photography, but they cannot do much more. The drone challenges are really, first of all, the energy. They cannot fly for long enough. The second is they cannot fly in windy conditions. So today we have wind gusts and the teams have difficulties to fly in that. And the third is they cannot interact successfully with the environment. So the environmental interactions are really the challenges. So the good news, however, is that there are solutions. And if you look at nature, we can advance that and implement principles of how to enable these solutions, how to address those. For example, in nature, we see that the spider has solved the question of how to use very little energy. So it used the net to stay aloft, observe the environment. It used the same net to move in the environment, and it can even sense the environment using an embodied intelligence concept of the net itself. So how can we copy this to drone technology? And we need a methodology how to do that cleanly and clearly. Now, I've spent the last 15 years of my life developing this and showcasing that on different robots. And how it works is that we need to be inspired by nature. We need to then translate this to the robot. And for that, we need to be very courageous and very off-mainstream, very out of the box. We can then apply the same principles from nature and build this into the engineering system that uses the same principles but looks very different. And Spider drone is one example where we copied the principles from the spider to the flying robot. Now, let me give you an example. Now, for me, this is a very exciting process to do. In fact, it allows me to take the living systems and bring the life into the technology. And I'm personally it's very satisfying to do this process. Now, let me give you an example of how this can make a difference in a real-world application. Let's say you have a hard-to-reach infrastructure elements, like an oil platform or any bridge, for example. Then we can have a spider drone that would fly there, create a support scaffold, that then another part of the spider drone can attach to, and like this save energy, be weather robust, and interact with the structures. Now, this visualization looks very nice, but the question is, how can we show that? Are we able to demonstrate that in hardware, in real prototypes? So this is in the lab environment where we show that even at small scales of butterfly-sized robots, we can show the same principles of how to anchor something in the environment. Now, I'm very excited to share with you today a concept that uses this way of anchoring, but also then allows the vehicle to shoot different anchors to the environment. So similar to Spider-Man, Spider drone also shoots different anchors and like this positions itself in the environment. Let me explain. So if you have the Spider drone, it would fly. Then a secondary anchor drone, or we call it the binder, takes off, attaches to a structure in the environment. And then the Spider drone shoots 2 anchors to the environment. Like this is fully positioned in 3D space without using any flight energy. It can also then interact with the environment. So Spider drone consists of several parts, which is the binder drone, the main platform, sensor pack, and this anchor module. And I'm very excited to share with you today the demonstration of that we have here. So here we have 3 drones, a family of Spider drones for you today here. The youngest drone is this one here that will take off to this structure here on top and anchor itself, hover, and then shoot the anchors to the environment to position itself. So it's a bit moody. It's the youngest drone. It's probably in its puberty, so it's actually a little bit moody sometimes. So let's see how this will go. So it takes off. It can then reach the top of this very small plate. It's about 10 centimeter sized plate that needs to stabilize itself to reach that. So it's a really challenging task, actually, to fly precisely. We use machine vision and SLAM methods to navigate in this environment. You can then perch, not use any energy, then use the propellers to stabilize and to steer while it does that, and then shoot to the environment. You see the two anchors. It has a CO2 canister that it can eject it at high speed to then position itself to the environment. So sometimes it can even recover. If you lose the contact, it can recover, fly again, reattach again, and like this, do that very robustly. Now today it's very windy, it's a lot of wind gusts, it's very challenging to fly here. And so we can do that. Now, as you've seen, flying far away from structures is easy here, just up in the stage. But interacting closely, that's the main challenge. And for this, we really developed this concept of having the spider drone attached to the structure to then demonstrate that. We have demonstrated this together with the nuclear industry in a nuclear fusion reactor, where we inspected the beryllium tiles inside of the reactor using similar methods. As you see, you can then steer, it can orient, it can have a virtual reality interface. As you see, Maxime has that, so it shoots the two anchors. As you've seen, it has done that successfully. It can then pull itself up, pull itself to the side, and even pull itself all the way to the side to then inspect the surfaces, for example, as you see now. So it can pull on the side and switch off the propeller, so it's completely safe now for me as a construction worker to interact with. And this is a very powerful tool then to augment the worker force and augment the capabilities. After that, it can take off again and re-land safely in the environment. Yeah, we can take off, it's fine. Now the other concept, depending on the environment, is to use an anchor, so to use a small anchor drone that would fly and attach itself to the environment using a string-based method. So instead of using magnets, which is possible in a bridge position, we can also take off with a smaller drone from the main platform and attach itself to the environment. As you see here, we can quickly demonstrate that and then fly off. You'll see that as I keep on talking. So the main challenging part here is to really fly and take off from the moving platform and then like this interact and anchor it even if there is no magnetic surface in the environment. So this one says hello as well. So the interaction is really challenging because of the aerodynamics involved. So taking one drone off from a main drone is very difficult. So you see here, for example, the interaction on a mechanical level, but even the aerodynamics involved or the control systems that need to be developed to do that is very challenging. So how do we address the challenges? So like this, you see it can take off. It can, like this as well, anchor itself to the environment. As you see in the slide, so we purge to save energy, we attach to it to save and be weather robust. Even in windy conditions, it stays robust like that, and it can interact with the environment. So this is really useful for inspection of bridges, for asbestos protection, corrosion, and everywhere where people put themselves at lives, and put their lives at risk. So Spider Drone is inspired from nature, and it takes the same concept into a completely new concept of a spider drone system that can be safe, but also is accessible to areas where safety is often not at highest priority. So it can really bring these technologies to these areas as well. So Spider Drone today has shown that it is possible to do that and apply this to the construction sector. And We will take this further with our industrial partners who are leaders in the construction industry for pilot projects, and also with our international team that consists of 13 members from 13 countries. So this is the first step towards a future city of future human-robot symbiosis. Thank you very much.
All right, thank you to our sixth team, that is Spider Drone. Unfortunately, I had to cut you a little short. Just to be fair to all the other teams, everybody gets the same time for setup, which is 2 minutes, and then we proceed with the presentation of 12 minutes. All right, the highlights on your screen right now. In the meantime, we're going to clear the stage for you and introduce our next team on stage, which is Twing Tech. That's our next team on stage.
All right, and while we're waiting for Twing Tech to set up, let's talk a little bit about what I said earlier about drone regulations. So if you're looking to get into drones, I've got a bit of advice for you. First and foremost, it's quite easy to go out in Dubai and find a drone like a little DJI Phantom or a Mavic, or if you're a budding filmmaker, then there's slightly more advanced drones like the Inspire, the M600. But you have to understand, Dubai actually launched regulations in 2015, and as of now, if you are buying a commercial drone equipped with a camera, you do have to register it with the Dubai Civil Aviation. They've actually put out quite a lot of information on their website. You can visit the Dubai Civil Aviation website at dcaa.gov.ae. And they've got a little bit of flyers over there that also educate you on where you can and where you can't fly, because, of course, as everyone knows, Dubai has some of the most congested airspace in the world, and integrating drones into it has been quite a challenge. I know that the authorities are actively working towards that. So once you're aware of that, once you've registered your drone, you're free to fly it in certain areas. But always remember, there's a bit of an etiquette that needs to be followed when you're flying a drone aircraft, because not everyone may appreciate a drone buzzing over their heads. So do take permission if you're flying near someone's house. Be mindful of people's privacy. Just observe a bit of common sense, and you should be all right. Go to the website. I do encourage you to go to the website and download those regulations so you can see what all those details are, but I can give you a brief overview of some of those details. You can't fly above 400 feet. There's two categories. If you're a business, there's a commercial category, and if you're a hobbyist, you will register under the hobbyist category, and they will issue you a little card, which will be your ID card, and that'll tie you with your ID to your drone, just the drone serial number as well. And once you've done with that, you also have to get a training certificate from the Sanad Academy. That, in a nutshell, is kind of how you should, how you would go about getting started with drones. But before you go out and spend, let's say, what, 5,000, 6,000 dirhams on a DJI Mavic or a Phantom, do go and get yourself one of those little toy quadcopters that can't really hurt someone. They're about the size of your hand, so they're not that big. It's about that big. And you can learn to fly that in your backyard, inside your apartment. They're made of cheap plastic. They don't weigh much. They can't hurt anybody. And that would allow you to essentially get the skills you need necessary to pilot the drone. Because piloting drones, while our contestants here have been doing it for a while, they make it look easy. It is quite a bit of a challenge, because drones can be quite complicated. There's a lot, GPS mode, ADI mode. Sometimes you have to learn to fly without that assistance if there's an emergency. So just do bear in mind to get one of those little tiny drones. They're not that expensive. It's a worthwhile Setting up. Marwan, I believe we're ready to go. So
Yes, we are. And our next team is team number 7. Please put your hands together for Twing Tech. You have 12 minutes to impress the judges.
Your Excellencies, ladies and gentlemen, it's a great pleasure to be here at this awesome event. I'm Rolf.
I'm Corey.
And we're here with Dino and Cedric to present you the energy drone. Now, energy transforms the world. This is Hong Kong in 1850, and this is Hong Kong today. This stunning development has been possible as mankind started to unlock the incredible power of fossil fuels about 150 years ago. This led to an incredible increase in wealth, health, population, but also not so long ago, we started to realize that this growth has limits. An economy based on fossil fuels destroys the landscape, pollutes the air, increases CO2 levels, melts the polar ice, leads to droughts, hunger, and social crisis. However, we start to act. Renewables are on the rise. Dubai is setting up one of the biggest solar parks of the world. Congratulations, you're doing good. However, renewables only add up to about 2% of the global energy demand. We have to speed up our efforts. Time is pressing. Now, wind is an abundant energy resource. Close to the ground, wind conditions are typically fair, but higher up, fair wind turns into excellent one. Can easily sustain a multiple of the global energy demand. Nevertheless, wind turbines can only harness a small fraction of this energy. They're massive structures which stick to the ground. They cannot reach the strong winds higher up. So in a diagram like this, we have to put the wind turbine on the bottom left corner. Now we have developed a new wind energy technology which can easily go high up where the strong winds prevail and which uses just a small fraction of the material of a wind turbine. And guess what? It's a drone. It's the energy drone, the drone that produces electricity out of the wind. Now, Corey, can you explain how this works?
I'd love to. So, how can we build an energy drone? Well, you need 5 things. A plane, a multicopter, a tether, a winch, and the wind, which obviously we have a lot of today. So let me start with the plane. And we're going to hook it to the winch with the tether. Essentially what we have is a kite. If you fly a kite in strong winds, you can produce a huge amount of force. And because the tether is connected to the winch, we can convert the pull of the wing into rotation, driving an electric generator and producing electricity. But what happens when there's no wind on the ground and there's a lot of wind higher up? What happens if our wing is flying and suddenly the wind stops? How can we get our wings safely up and down? Yep, you got it, the multicopter. By integrating a multicopter onto our wing, we can have fully automated launching and landing in all conditions. Your Excellencies, ladies and gentlemen, the moment you've all been waiting for. We have been working over the past 3 years to develop the energy drone. And we would like to present it to you for the first time here today. Thank you. So we're 5 minutes left. Demo. So now that you've met the energy drone, we're going to make a short demonstration. Normally, we would go to a wide open field, and we would hover out to about 150 meters and fly huge loops in the sky to produce power. We don't have the space or the permission to do that for you here today, so we're just going to do a short hover. This will show you how the energy drone can launch and land. So our test team's just getting set up. I think we're almost ready to go. Safety first. We all got our hard helmets on. So, Dino, how's it looking? All right, let's do it. What it is? So it looks like our energy drone is being a bit sleepy here. Dino's going to check out what's going on, and we'll continue. We'll show you a quick video so you see the system in full action. Oh, man. No video. Sorry about this. Here you go.
Imagine generating electricity from the wind with a wing on a tether. Would you call it a drone, a plane, a kite? It flies high where the wind is strong and constant, and it doesn't need a huge tower or foundation. Welcome to the next generation of wind energy. Welcome to Twing Tech.
So with all this talk about energy, you might be wondering how much an energy drone could produce. Our model here can produce about 1 kilowatt. But of course, the idea is to build much larger drones to produce energy for cities, communities, and eventually the world. The TT100 is our first product. It'll integrate into a 20-foot shipping container so it can be shipped easily around the world. Seamless integration with diesel generators, so you have power even without any wind. We're going to set these up in communities, mines, and resorts. We can help people produce power when they're in crisis and rebuild disaster zones. We will set these up on the land
or on the sea, where we can put it on floating platforms. Now, an array of 20 by 20 of these big systems will produce 1 gigawatt of electrical power. We call this the Giga Island. It has about the dimension of the palm, but we will set it up further out in the Gulf or in the open sea, where it can produce very strong energy demands in strong winds. We can produce energy and hydrogen out of this and ship it over the world as it's done today with fossil fuels. But this energy will be clean, it will be taken out of the wind, and it will be sustainable. Ladies and gentlemen, this is Dubai in 1991. 25 years, energy has transformed this place too. We have now the unique opportunity, and this is a singular moment in human history, to invest part of the wealth created by the gift of oil to transform the fossil economy into a sustainable economy. And to do good for the poor, the weak, for our children and grandchildren, for generations to come, for every living being on this planet, with the help of a drone, an energy drone.
All right, that's all we have time for.
Thank you very
Twin
much.
Tech, I'm afraid the time is up. Thank you for the demonstration. All right, next up, we invite Nokia Saving Lives as Twin Tech clear the stage and Nokia Saving Lives make their way to the stage for their setup. 3 more teams left to go in the International Drones for Good Awards. And I'm noticing some technical difficulties that some people seem to be facing over the past few teams.
Yes, you have to understand, when you are shipping drones from one country to another, obviously some of these drones are large drones, you got to break them down to their core components, and then you got to rebuild them when you get to the site. That's usually not the case when you're actually deploying them in the field, but in this case, when you're building these things again, sometimes you could encounter, there's a potential for technical issues to occur, and that does happen occasionally. But it's all part of the show, and they had a great demonstration. Also, they're one of the only teams over here that are actually working on energy generation using drones. We've never even heard of that concept before Twing Tech introduced that to us. And they've come to us all the way from Switzerland. And it was interesting, I was talking to the team, the idea came to them while they were kite surfing. And I was quite impressed with how they were explaining it to us, because getting these wing-style drones down once the wind dies out, having a quadcopter there to land it safely, it's quite ingenious. Let's talk a little bit about Team Nokia. They're up next, and again, this is a very, very technical solution. Let me tell my audience a little bit about what's happening in the drone world. So we spent the first couple of years in the drone industry trying to figure out how to get drones to fly, right? And then eventually, as you've noticed, drones have become safer, they fly a lot longer. So now a lot of companies and individuals are focusing on payloads. You know, what can we do next? And that basically means that people are working on payloads, software to make drones more useful. And Nokia, for us, have a solution for disaster management today. And it's working on the LTE band. For those of you that are familiar with the cell phone we have on our phones that allows us back. When we have an earthquake in a country or there's some kind of crisis, one of the first things that goes down is the communications network, because people are trying to call in. Sometimes there's electrical problems, so you can't really phone in. And this kind of rapid deployable comms network by Nokia, who obviously have that kind of experience from building cell phones and communication networks, they're using so we've got 2 more teams in quite a few of those pop up. And
what does that mean?
Hybrid VTOL is basically a drone that leverages the best of both worlds, right? So you have quadcopters and hexacopters. They can't really fly for long durations because there's no wing surface on the copter. It's just using the motors and the propellers to generate lift. That's quite the energy consumption on that's quite high. Aircraft are more efficient. So when you're doing long-range mapping and things like that, that's why we had Avy over here with the aircraft-style solution. You need the wings to do all the heavy lifting. So you're just running 1 or 2 motors. It's quite energy efficient. You can stay up in the air for hours. Hybrid VTOLs combine both of those technologies. So they're the best of both worlds. So if you're talking about drone deliveries, eventually you'll probably see hybrid VTOLs carrying those out. Those of you that have been following Amazon in the news, you'll realize the Amazon drone actually has hybrid VTOL sort of designs, and so does Google as well with their Google Project Wing. Last team up is Minekafon, which are working on a demining solution. They were actually also out on YouTube with a Kickstarter video. A lot of people have heard of them from that. They were immigrants into, I think, the Netherlands, I believe. And they've come in all the way from Afghanistan, and they wanted to solve problems about the mining problem, the minefields in Afghanistan. And they worked on their drone specifically to target that problem.
All right, great. Some great information over there. I believe the 2 minutes up for our next team, Nokia Saving Lives. So as soon as we get the thumbs up from the guys on stage, we could start with their 12 minutes to present and impress our judges up in the judging booths. All right, here we go. Ready to go. Our next team, please put your hands together for Nokia Saving Lives.
Hello, I'm Colin van Hartenberg, and I'm the project leader of Nokia Saving Lives. And this is the Nokia Saving Lives team. Nokia Saving Lives, what is that? That's an innovation project of Nokia. At the same time, it's a non-profit initiative in the humanitarian field. We want to bring new technology to the disaster area when the disaster has happened and put it really into use. But before we go into that, let me give you an overview over that, what Nokia Saving Lives is about. And in that initiative, we have 7 components. And the first one, and that's the reason why we are here, are the drones. We have special purpose drones, and you will see them flying later. We have special purpose drones which are weatherproof, which do have a special carbon fiber hardened body to withstand impact. We have them flying autonomously, controlled over LTE. And we have 2 radios built into them, an LTE connection and the standard analog connection. And they support real-time video streaming over larger distances. They can carry different payloads, and they would support a traffic management functionality if it's enabled. Secondly, we have them flying in a swarm formation. Swarm formation means, in fact, that they are flying in a synchronized mode over the area which is to be searched. Or they could perform differentiated tasks at the same time. And that helps this synchronized flying, that we only need 1 pilot and not many pilots to operate a group of drones. Because our drones, as I said, are flying in larger numbers. We don't want to have only 1 drone flying. Just imagine a disaster area and you would see a large group of drones flying over that, all streaming video and other data down. And you can imagine what amount of data would be needed to be transferred down to the rescue team. And that's why we built on LTE, and Phil will talk more about the LTE.
Thank you, Colin. Nokia Saving Lives provides an end-to-end LTE network for emergency search and rescue operations. This is critical because in these disaster areas, the existing cellular communication systems may be out of service. Only rescue team members can actually access the system that we provide, and we provide a bubble of coverage for LTE very quickly. Everything from our LTE system can actually fit in this single backpack here. Normally, you would take a small room of equipment to provide an LTE system, but we'd have everything self-contained in one backpack. We can actually get this system up and running in a very few minutes. The LTE system includes a base station, or eNode B, an enhanced packet core, and all of this is integrated into a commercial Nokia LTE small cell. We can provide many square kilometers of cellular coverage very quickly. This is quite different than a typical Wi-Fi or analog solution that you would see today. Our network for Nokia Saving Lives provides a bunch of functions. Control communications and video streaming for our drones, data and voice connectivity for the handsets that all of our rescue mission team will have, and then links to our command center here for command and control. The second key piece of infrastructure for our Nokia Saving Lives system is our command center. We can operate search and rescue missions all from this central location. And with an internet connection connected to our LTE system, we can actually do this control remotely from anywhere in the world. Many rescue teams actually have monitor and managing functions in a remote location. Thanks, Colin.
Okay, I think we need to speed up. So the next one is a ground operation team, which comes from Nokia and is determined to be on the ground, in the field, where the rescue operation works. So Nokia Saving Lives has this built in as a part of its concept. And then, to speed forward, is, of course, there needs to be collaboration with a rescue operation. What is it good if we are there, but nobody uses that data? So Nokia Saving Lives builds on collaboration with rescue organizations in the world. And last but not least, what is an LTE network which you bring in good if it's not accepted by the local regulator or by the operators who own the frequencies? So again, this is something what we are looking for. And now I think we should be ready, Phil. Is that okay?
Yes. Arto, are we ready to launch the drones? Okay, as you can see, Arto is monitoring the search from our control center. Tommy out in front is our emergency pilot. And I'm Phil, in charge of the operation for today. The screen on the right is actually showing the drones as they're flying. The screen on the left is actually showing our control center in action. There's three key windows here. You see the mission map on the left, the HD video on top, and the thermal video on the bottom. Arto, let's begin the search.
So let me give you a bit more explanation why these two drones are flying. I mentioned before that we want to fly in larger numbers, actually. Here we fly with two. And that's because the space to be searched here is quite limited. Now we pretend that this lake is a disaster area, and the disaster area needs to be searched by one drone. The other drone is put up into the air to scan the whole scenario and see how it develops. So one drone is flying at a higher altitude, about 50 meters, and the other one is following a search pattern. You would typically see 2 or 3 drones going in parallel to follow that search pattern. Today, only one. Phil, as our pretended rescue mission lead, will interrupt me when the drones will find something.
That's great timing, Colin, because I think we actually have found something here. The orange dot on the screen indicates that we've located our first target. You can see from the thermal window that we are also flashing orange here. This indicates a medium priority target. Now, the key thing to understand about our complete solution is that not only can you see it on the control center, as can people in the control center or remotely, as we discussed, but all the team members can actually see the same window on their handsets as well. Okay, Arto, let's continue the search for our next target.
Okay, while the drones now will continue their search, they found the first one. Let's give some more explanations about our solution altogether. Again, imagine when you see on these both screens the video stream and the thermal video stream, if you would have more than 2 drones, 4, 5, 6 drones flying, how much video data would need to be transported? And because there is so much data to be reviewed, and because you would need so many different analysts to look at the screens, we are building with our control center a data analysis function which allows the software to recognize those topics of concern or of a priority. So in our situation here, the software has recognized the person on the ground as an object to be saved, but at the same time put it as a lower priority of, for example, a person which would be in the water. And while this is going on, we can see that the other drone is hovering or is moving slightly its position.
Excuse me, Colin. We've actually found our second target here. You can see from the map that in this case, the dot is blinking red, and the thermal window itself is blinking red as well. This actually indicates a high priority target. In this case, the reason for it being high priority is that it's in the water. And again, our complete team can see these same views and retrieve the GPS coordinates so that the rescue can begin immediately.
I think, Phil, we need to return right away. I got the sign that we have only 1 minute left.
Okay. Arto, can we go ahead and do a fast pass back here?
So the drones should be now returning, and we plan to have a bit of music with this, with the drones coming back. In the return flight, the drones follow an automated logic. So they will find their way home based on the flight path determined up front by the software. It should take about 30 seconds until they are down.
All right, Nokia saving lives. Your time is up. If you can just fly that drone back. And once again, put your hands together for Nokia saving lives. All right, while we give them a few moments just to clear the stage, our next team presenting is Wingcopter. All right, your highlights on the screen right now, and Wingcopter getting ready to set up. 2 more teams left to go here in international drones for good. And here you go, highlights on the screen right now. All right, as we get ready for our next team to set up, it is Wingcopter. 2 more teams left to go. As you can see, some smoke coming out of their drone, and nothing to worry about, ladies and gentlemen. I think it was supposed to be part of their presentation, which accidentally got triggered off a little early, unfortunately. So a little bit of early performance for you, I guess.
I guess so, yes. So let's talk a little bit about Wingcopter. We were talking about hybrid VTOLs, and I was having a chat with Tom from Wingcopter. They've come to us all the way down from Germany, and they've got 3 drones on display. I believe they are also colored their drones in the Dubai Police, the Fire and Rescue Department as well, in the color schemes.
Actually, if you pay attention to the smoke that's coming out of the first drone, it's in the color of the flag of the UAE as well.
Oh, that's very thoughtful.
All right, so these guys are the team before the last in our international category. Wingcopter currently setting up. As soon as they're done, we have one more team left to go, and that is Minekafon. And then we take a very, very, very small break just to get our new set of teams in. And that is our national category. All right, coming up in the national category today, Sanad Academy, drones for search and rescue, Firefly, Intelli drones, customizable drones, and Saad. And then we also have Iorta, Finder drone, and East Hawk, followed by the awards ceremony here on stage. So we got a fun-filled afternoon for you, and it's great to see that the clouds are clearing up as well. Sun is shining, the weather is beautiful. A great day for the 4 Good Awards, both the UAE AI and Robotics for Good Awards finals going to be announced today, and the UAE Drones for Good Awards. All right, just a few more moments, I think, before Wingcopter is ready to go. And I know that these guys are super excited about presenting their presentation. They were at the booth right next to us, and we could overhear them really excited about what we have in store. And 3 drones on stage. Do we call these drones as well, Shaban?
Yes, they're all drones, of course. They've got intelligence, they've got autopilots, you can connect to them over computers. There's a lot of advanced features in there, so definitely.
All right, here we go. Ready to go. Please put your hands together for our 9th team in the international category. This is Wingcopter. 12 minutes to impress the judges.
Thank you very much for listening today to our show. And sorry, there should be a film running. If I press play. Okay, great. And music, hopefully. Can I get the music as well? Guys? Where's the sound? Sorry. There's the film and sound. I would like to have that if that's possible, because then I can present well. Thank you, and the film. So, sorry for that. All right. Actually, it has been 5 years for us of work to be here today, day and night, honestly. And today I want to take you on a journey, because, please, volume up, if that's possible. Thank you. Because I want to take you into future. Because what we invented and what will make history is the so-called tilt rotor mechanism, as you can see in the film right now, and later in action. This tilt rotor mechanism actually enables our drone, called Wingcopter, to start vertical, as you know it from multicopters, take off vertical, land vertical, and hover. However, once up in the air, we are able to tilt the mechanism 90 degrees and then fly like a fixed wing system. So by tilting, we can fly faster, on a much more longer endurance, and on a wide range, far more than normal multicopters. So when we built the first models, we realized the potential. 5 years ago, there was non-transition drone at all. We were the first people building this, and therefore we were also able to get a patent for the idea of tilting. So we started working more and more on this. We used glass fiber, carbon fiber, tried to finance everything with our own money, we were students at that time. So we just believed in this dream to build a fully new drone which was not there before, and combining all the good benefits of these 2 drone kinds, fixed wings and multicopters. So we made it ultra lightweight. And at some point, we went deeper into the technology and programmed our own flight control algorithm to make it more and more alive. And today, 100% fully autonomous, as well as super manual steering as well, so you can decide which one you want to fly, fully autonomous or manual. Yeah, and so at that point, after basically the first 3 years, we were at this point where we had the first Wingcopter, which is, yeah, it turned out to be a golden one because the first demonstration was supposed to be in UAE, and we thought, why not make it just golden, because it was just we were just super proud to have it. And yeah, we will keep that one as just our memory. And then we went on to build 3 more models for this show today, as we got invited to the Drones for Good, because we thought what we really want to do with it is to save lives and to use all these benefits of this copter to have a more efficient search and rescue mission, which I present very soon. So before I present that one, I want to just get one more time back to the core idea. You all know multicopters, as I told you, the one with the 4 propellers or 8 propellers. And the idea of that is you can take off vertical and hover. That's quite fine, but maybe by using it for the last 2 years, 3 years, 4 years, all of you maybe, you probably get bored of the time, of the flight time, because it's very limited, the speed is very limited. Then again, there are fixed wing systems. They can fly fast, they can fly wide, but then again, you need a runway to start them, or a lot of space to launch them, or even a catapult. So what we did, we combined both ideas, and what came out was a revolution. It was the Wingcopter. And normally, here it is. Okay, great. So, sorry, it's the first time I'm standing here, honestly, in front of so many people, so I'm a little nervous. But okay, enough talk, I think. We should start directly with the show, because there are 3 waiting for you. So, none more talk. Okay, that was the idea, tilting. Come on, tilt. Yes. Okay, we can tilt. That's the basic idea. Very simple, but super strong, as you will see right now. So let's go into the film. Normally, I was supposed to say more about payload, but I know time is running, so let's go straight into the show. So when we came first to Dubai, what we did is we met the police. There should be some music. Perfect, thank you. So when we met the police, we were able to get to know the search and rescue teams in UAE, and they showed us what they are doing on land and on water. So we really liked their work, and we thought, okay, if we use the Wingcopter, combining with their work, we can really make a great effort in making their service more efficient, the search and rescue service. And for the show today, we want to concentrate on the water. So let me bring up the first drone. Is it fine? Can we do it? All right, great. So that one is the police drone, the police Wingcopter. As you will see now, the takeoff, vertical. And once up in the air, straight up, you will now see the benefits of this tilting mechanism, which is totally new and our invention, as I said. When we turn in a minute, we will, or in a second, we will tilt the rotors, and then you will see the speed of what I was talking about. Okay, the idea is to have a live picture on this drone. Normally, it's not working it seems, but normally there should be a live picture so we can monitor the sky. And then again, the idea was if there's a person out in the water, we can find this person, detect it with GPS sensors, and we also integrated a live buoy, so we can drop it in the water so the person is safe. So, as you can see, if you like, come down, let's drop it, because the time is running a little bit. Okay, Mark, can you start the next one? We have to go, the time is running. So we have a second one. The buoy will start, we will show it right now with the cameras, but then, because time is running, I start the second one. This one is supposed to, the first drone is supposed to save the person from drowning. So there's a buoy which will be small, but big enough to save the person from going under the water. With this drone, it's the second one, we operate in a swarm. So that's a fleet of Wingcopters, basically saving a life in the water. So this drone actually will go right away to the water and drops a live raft by 2 by 2 meters. So with this, because the main death is the main people dying not from just being in the water drowning, they die from undercooling. So this idea with this drone is actually that we can drop this life raft and save the person, because once in the water, hopefully we see it on camera. Can we put the cameras on it? Thank you. You will see it will unfold in a way that a person can swim inside, and these 2 by 2 meters will totally save him from even getting too cool in the water. Because imagine someone is out in the ocean and getting just too cool. It is not enough to detect him with a camera or bring a little buoy which can save him from drowning. No, we need this kind of raft to have him inside to wait for the boat. Okay, next one, last one. The idea with this is, after the person is saved, we can still bring a delivery box. You saw it today, drone delivery. That's a big issue. The Wingcopter is perfect for it. Because with a drone, with the transportation box attached, we can bring the media kit directly to the person injured or to the rescue team which is with the person but needs maybe urgent medication, maybe blood, or maybe any other thing which can fit in this box. So we will just demonstrate you how we can drop it, because what we inbuilt with this is not only a box, we also built our own release mechanism. So normally it can take the box, but to save time we just put it under it, but it can also release the box automatically. So we can not only drop things, we can also deliver things. And yeah, you can just bring it down and show it that we can. Just come back and show me, okay. So we just want to show that we can lift the box and also bring the box, deliver it to the point of destination. And then the drone actually, now it's unlocked, fully autonomous, and you can start again. So here we go. The box is delivered, copter comes back. Mission completed. Thank you very much. Okay, all guys? Guys? Michi, Mark, Andy. By the way, that's our pilots. And record-winning pilots from Germany, so they're really good. We just took them as, I know it's fully autonomous, but we took them as in a way that we want to show now a final show, which I hopefully can start now. So can you all just, thank you very much. Sorry, it's just the time pressure which makes me a little hectic, but can I get the music for one more time, please? Can I get the music, please? There should be music running normally. Wait. Okay, I make it. Thank you. Okay, that's basically another very good feature. We fly super dynamic with this tilt mechanism. So as you just saw, there was a looping. And yeah, as I said, these pilots are super cool. So just maybe enjoy that last show before we come down to show what we can do, because we are super stable in wind. We can even fly in rain, so we actually love that weather today. And yeah, maybe just enjoy the show. I stop talking now. So thank you very much.
All right, what a great performance there, and a presentation from Wingcopter, and also managed to finish right on time. I didn't have to interrupt them.
And the audience certainly appreciates this demonstration. Tom talked about being nervous. There's no need to be nervous. I think their drones are coming back one by one, and as soon as we've got clearance, so we can move on to the next team. But what an amazing, amazing demonstration here. We saw payload delivery, we saw a little bit of smoke and smoke effects with their drones. And we saw search and rescue happen all in one demonstration.
And also the highlights on the screen right now, if you want to take a look at what was going on over there. I mean, they did a fantastic job at also not worrying about what happened early. I mean, you know, it was clear that I think they triggered off one of the smoke or colored smoke off one of their drones, but, you know, they kept the show going. As they say, the show must go on, and that's exactly what they did. And, you know, it's always nervous being on stage and presenting, but I think they did a fantastic job just pulling through, which is always the most important thing. And I also want to highlight one thing. In the last 3 years, the first time I've really seen 3 drones in one presentation, too.
3 wing drones in one presentation doing 3 different things all successfully. So yes, that is quite an achievement.
Yep, we're definitely impressed, but you know, the people that you need to impress is our 8 judges up there currently putting the scores in. And of course, the audience who are giving you a round of applause, you can vote for your favorite teams, whoever they are, by logging on to the website and giving them a vote. The website is A4G.ae. That's called the People's Choice Award, so you can actually head over there and vote for your favorite teams. Voting is open 30 minutes after every single team performs, so you can go ahead and do that. Coming up next, our final team in the international category, and these guys go by the name of Minekafon.
Minekafon are working on a landmine removal solution, and they've come to us all the way down from the Netherlands. It's our last international team for this segment before we move on to the national categories. First 6 teams are going to go up, and then we're going to have 3 more teams towards the end for a total of 9 teams.
All right, great. A few minutes for them to set up over here. Ladies and gentlemen, if you have joined us, welcome to the UAE for Good Awards. Once we're done with the international category over here, we move on to the national category, and then we announce all the winners with the awards ceremony happening today as well. Don't forget, if you're on the social media, the hashtag is UAEA4G. You could use that hashtag if you're posting pictures on your social media. And of course, the website to check out for the voting, once again, a4g.ae. And let's also talk about the fact that you can win 2 Mavic DJI drones by just registering on the website. All you have to do is log on to the website awardsforgood.ae and register for your chance to win not 1, but 2 DJI Mavic drones can be yours. And I'll tell you, this is a great drone to win. If you do get a chance and have a few moments, you could do it off your phone. I see a few people already picked up their phone and doing it right now, which is a great idea. I highly recommend you do it.
And while we're waiting for our team to set up, let's talk a bit about Minekafon team's idea. So what you see here on stage is commercial DJI aircraft, but remember I talked about earlier about people working now on payload deliveries and the software side of things. So Minekafon is essentially what they're doing is they're trying to get a mobile airborne metal detection system, and they fly that close to the ground so it can detect where the mines are. Then they have a system that's able to mark where those mines are with a bit of paint, and they also log the GPS coordinates, and they're able to cover a lot of area, because once you use a drone, you're above the ground, so you're away from the danger zone, and you can fly around freely without any restrictions, without any fear of triggering mines. It keeps people out of harm's way, and you can cover a lot of area compared to traditional demining techniques, and that's what we're going to have on display for us in a few minutes.
All right, great. I think the time is almost up to set up so we can get them rolling on the clock. 12 minutes to present to our judges here today. And again, our final team in International Drone for Good Awards, national team coming up very, very soon as well. All right, we just got told that the next team is ready to go. Ladies and gentlemen, please put your hands together for Minekafon.
You have to click.
Every single day on this planet, someone is injured or killed by a landmine. Removing them is very time-consuming and dangerous. Millions of landmines litter the landscapes of the war-torn countries around the world. My name is Masoud Hassani, and I want to change this. Our mission is to solve the landmine problems within 10 years. In 2012, we have launched our first Kickstarter campaign. It is called the Minekafon. A low-cost wind-powered anti-landmine detonator. It rolls along on a desert. When it hits a landmine, it blows itself up and it destroys the landmine at the same time. After 3 years of hard work, we brought our mission to the next level. Now we are very excited to introduce you our newest robotic invention, the Minekafon drone. It is an airborne demining system which aims to reduce landmines in less than 10 years globally. Minekafon drone flies above a dangerous area. It generates a 3D map. Then it detects landmines with a metal detector and GPS coordinates. The drone has a robotic arm which places detonators on top of a landmine and blows them up from a safe distance. These three methodologies combined makes the Minekafon drones up to 20 times faster than the traditional technologies. It is safer and up to 200 times cheaper. Imagine if we could fly with hundreds of Minekafon drones all over the affected landscapes worldwide and free the world from landmines. Now it's our final goal to bring the Minekafon drones to a pilot in order to be able to test them on different environments and weather conditions. This is needed to prove and show to the demining organizations that the Minekafon drone is faster, cheaper and safer than the existing technologies. With such a disruptive approach, we could save thousands of lives. We need your support to make this happen. Please join our campaign and let's have a landmine-free world, because one less landmine means one saved life. We are looking forward to collaborate with you on this project.
Hi everyone, my name is Masoud Hassani, and this is my team. We are from the Minekafon. We are coming from the Netherlands. And our project is to reduce landmines in 10 years' time. And I was born in Afghanistan, and I was living in a place where there were a lot of landmines. So we have seen our friends getting they got killed by this kind of landmines, and also relatives. So this is our mission, to reduce landmines in 10 years' time. We want to use the new technologies. In the video, I've seen our previous drones flying. Now we are working on a new robotics. So worldwide, there are about 1 billion people at risk. So worldwide, there are plus 60 countries. And this is our application, which shows where they are. And the traditional way, the landmines are cleared very slow. It takes days or months to do this field. And the problem is with animals and really old metal detectors. So we have seen in the video, could fly actually unmanned, so no people or no deminer will be at risk on a really dangerous zone. So we will now introduce you the three steps of airborne demining system. And so we have seen already our mapping. So this is the mapping system. A drone flies around with 4 cameras on board to 3D map a whole area. So this is very fast system. And after that, every danger zone is pinpointed then, and then we fly with the real detector. So now we are going to the demo. So I will fly now the drone with the metal detector on board. We will try to detect 3 landmines who are already hidden in the podium, 1 and 2 on the grass field. So Adrian, metal detector to 1 meter. So now we are releasing the metal detector. So this means when the drone is a danger, or if there are grass fields, nobody will risk their life. So basically, we can fly with this metal detector around. And for example, if there is a landmine, we go here. So we have mapped the first landmine. You can see it also on that screen where that is. So now we are going to another landmine. So now this is a very old landmine. It has minimum amount of metal. So we try to detect this one also. So this is minimum amount. This is only 3 grams. Here is only 3 grams of landmine. So you can hear it already a little bit. So now we go to a bigger landmine. La pêche, c'est super. Now we are putting back the drone and we will connect the robotic arm. So, Radion. So here we are going to land now. How's it going? Okay, so now we have only 1 minute time to change. Okay. So here we are attaching our connection to the drone, since there's a lot of vibration with the air. Adrian. Go with your left. So what we do is actually, we have seen it already in the movie, the drones places a detonator because on top of a landmine. So once it's nearby it, we place the detonator and then it flies away. So after few seconds, then we make the sound. So this is then, there was an explosion. So this is a very effective and fast system to find landmines in the fastest way. So we will reduce time up to 200 times faster than the traditional technologies and save millions of lives.
All right, I'm afraid that's all we have time for here today. Minekafon, a round of applause for them, please, with another great demonstration. And our final team in the international category. All right, sending you over to the screens to check out the highlights of our last team. We'll be back in just a few moments to explain what's coming up next in our national category of the Drones for Good.